So, hi guys. This is another video concerned with sound waves. Those are the hints that I want to give to you guys in instances where you want to attempt previous question papers or how to answer certain types of questions concerning sound waves in the exam or in tests. So, we've already done longitudinal waves, and I said that longitudinal waves refer to waves in which the particles of the medium they move parallel to the direction of motion of the wave. I also said that you have to establish that we have compressions and rarefactions, and in terms of compressions, the particles are close to one another, indicating high pressure. And in terms of rarefactions, the particles are further from one another, indicating low pressure. And I said that the distance from one compression to another compression, or the distance from one rarefaction to another rarefaction, that is what we refer to as the wavelength. I also taught you guys how to establish frequency in a graph in both a transverse wave and a longitudinal wave. But in instances where you're gonna have questions, you're very much welcome to send me a text message via WhatsApp, and I'll respond to you and explain to you how do you go about with establishing frequency in a longitudinal wave. And I also said that we begin with sound waves. In waves we're gonna do sound waves and light waves. So in the aspect of sound waves, I said that when you're having a conversation with your friend, for that specific message for you to be able to reach your friend, it needs to move through something as a message, and then it can then be converted in their ears for them to hear what you're saying. And I said that sound waves falls under the category of longitudinal waves simply because longitudinal waves require a medium for them to transmit energy. So sound waves as well also require a medium for them to transmit energy. Okay, fine. And I said that so they require a medium for them to transmit energy. And I said that we have three instances of mediums, types of mediums that we have. Initially, I said that a medium is a substance that the particles use to transmit energy. So, what types of mediums do you have? Um, so we have water can serve as a medium, air can serve as a medium, or a solid material can serve as a medium. So I said this is what sound waves use to transmit energy as well. Okay, and I said that there's gonna be instances where they're gonna ask you a question, maybe for 2 marks in the multiple choice question or in the question in the exam, where they're gonna say, looking at the types of mediums that we have, that sound waves use to transmit energy, which medium do you think the particles, or no, which medium do you think the waves will travel the fastest in? And I said, how do you go about with attempting this type of question? I said, you're going to look at this. For a solid material, the particles, I said, they are close to one another. It is something of this nature, close to one another. And I said in a liquid material also, including water, um, liquid, not water only, liquid. I said that the particles are close to one another, but they are not close to one another like how they were in a solid material. And I said that in instances where you're gonna have gas, the particles are scattered, they're all over the place, they're not close to one another. So that is how the particles are differentiating between the types of mediums. So if you're looking at the types of medium that you have, solid, liquid, gas, you need to establish which type of medium do you think the sound waves would move fastest in. So when we're concerned with where they would move the fastest in, you look at the type of particles that you have. How fast the medium moves is determined by the medium that you have and how close the particles are. So looking at the solid material, you can see that the particles are close to one another. They are so close to one another. So that means as the sound waves move from one particle to another particle, it'll be easy for them to move, or they will move faster from one particle to another particle. Looking at the liquid material, comparing it to a solid material, the particles are close to one another, but they are not that close to one another. So to establish how fast the sound waves would move in a solid or a liquid material, you can see that in a liquid material, yes, they would move fast, but they would not move the fastest compared to a solid material because the particles of a liquid material are not close to one another than how they are in a solid material. In a solid material, I said, it'll be easier for the sound waves to move from one particle to another particle. They will move faster from one particle to another particle. In a liquid material, yes, they would move faster from one particle to another particle, but comparing it to a solid material, it is impossible. They would not move the fastest in. And looking at a gas material, the particles are scattered there all over the place. So looking at the particles that are scattered, you need to establish how fast will the sound waves move in these particles. Looking at the particles, it'll be, yes, they would move faster from one particle to another particle, but comparing a gas to a liquid, particles are close to one another, so that means in a liquid material, the sound waves would move the fastest in a liquid material than how they would in a gas material. So, comparing a liquid material to a solid material, because the particles of a solid material are closer to one another, that means the sound waves would move the fastest in a solid material compared to how they would in a liquid material. So the answer would be that the particles would move the fastest in a solid material because the particles are close to one another. So, what influences the speed of a sound wave? What influences the speed of a sound wave? Hints that I'm going to give to you guys. Number one, what influences the speed of a sound wave is the type of medium that you have. The type of medium that you have is an influence on how fast specific waves would move. So if you're a solid material, for sure they're going to move the fastest in. So if they give you a solid material in the facts and they say that compare this solid material to a liquid material and establish whether or not the sound waves would move the fastest in. Remember, solid material, they would always move the fastest in the solid. You compare, guys, you compare the particles um for each and every phase for solid liquid gas you compare. So if an instance is whether they're going to give you a liquid and the gas, you're going to compare liquid and the gas excluding a solid and establish whether or not the particles are which phase has the particles that are close to one another, and if the particles are close to one another, that means the sound wave would be the fastest. And also number two, the speed of a sound, or how fast um the sound waves are moving, depends on the temperature of a medium. I said to you guys, if if the temperature increases, this is going to have an effect in the speed of the wave, or how fast the specific wave is moving. Because if initially you had let's say you have wave speed of 300 meters in a second, and they say that the temperature is 0 degrees Celsius. So if you increase the temperature to 20 degrees Celsius, there's a high possibility that the wave speed will also increase, and maybe would range around 340 meters in a second. Reason why? Because the increase in the temperature has an effect in the increase of the wave speed. So in simple term, the higher the temperature, the higher is the temperature, the higher or the higher the wave speed is. So wave speed is influenced by the type of medium that you have, also the temperature of the medium. Okay. And then number three, also what has an effect on sound waves or speed of a wave? So, as I said, sound waves are pressure waves. So, the more you exert pressure on the sound wave, the faster the sound wave would move. So, if you put pressure or you exert pressure on a sound wave, exerting that pressure would have an effect in how fast that specific wave is moving. Okay, so let's say, for example, they say at sea level, the air pressure is higher than higher up in the mountain. The pressure, depending on the aspect, pressure being high, the higher the pressure, the faster the sound waves would move, or the faster is the speed of the wave. So, similar to temperature, the higher the temperature, the faster the wave speed, or the higher the wave speed. The higher the pressure being exerted, the higher the wave speed. Simple. High wave pressure linked with high wave speed. So that is those are the three instances that influence how the speed of the wave increases or decreases. Number one, I said type of a medium that you have. You look at the particles of the medium. If they're close to one another compared to the one that you have, they would move the fastest in that particle in that medium. Number two, the temperature on that specific medium. The higher the temperature, the higher is the wave speed. Number three is the pressure being exerted on the medium or on the wave. The higher is the pressure in that specific medium, the higher is the wave speed. So those are the three instances that influence those are the in three instances that influence um wave speed. Quick. I want us to cover this in quick. So I also did reflections and echo. And I said that imagine yourself in an empty classroom. So if you are in an empty classroom and you shout so loud, you're gonna hear a reflection of the sound that you've already made simply because you're in a close area, and when the sound waves or when the sound energy is being transmitted from your mouth traveling through using the sound waves through the air particles, they're gonna hit back maybe the wall of that specific area that you're in, and then they're gonna reflect back to you for you to be able to hear them back. So that is what we are concerned with when you talk about echo. I said that echo is defined as a reflection of sound. That is what echo is defined as. Okay. And then a quick example, because a lot of people were confused on echo when we did this practice question in the tutorial. I said, for example, you have something of this nature. You have a ship and you have a cliff, a vertical cliff. So this is a ship, and it has this thing that it uses to transmit energy for it to be able to communicate or connect with maybe other ships in the area. Okay, so if you have something of this instance, and the statement says that the siren of the ship exerts a sound, and the sound is reflected back from the cliff. So that means that the sound moved from the siren to the cliff and it got reflected back to the siren. So let's assume the ship is stationary, it is not moving. So yeah, the sound moved from the siren to the cliff, and then because it is an echo, the sound reflected back to the source that has exerted that sound. And I say that maybe the wave speed it is 340 meters in the second, or the sound speed it is 340 meters in the second. And they say that the time it took for the sound to move from the siren to the person, no, the time it took for let's say, for example, let's assume there's a person in this instance. So let's say that they say the time it took for the person to hear back the sound that was exerted by the siren as a reflection, it took 4 seconds. So it took 4 seconds for the sound to reflect back to the siren. And they say that calculate the distance between the ship and the cliff. So this is the distance that you're concerned about. This is not wavelength. That is different from wavelength. And this is another instance where you're going to calculate wave speed in instances where you don't have frequency and wavelength. So they say that the wave speed is 340 meters in the second. And they say that the time it took for the reflection of the sound, it took 4 seconds. So in simple terms, they mean that it took 4 seconds for the sound to move from the siren to the cliff and the sound for it to reflect back. The total time for the sound to move from the source for it to reach the cliff and for it to be reflected back. So, for example, here in a classroom, I said, let's say you want to record the time you heard the sound when it got reflected. Let's say maybe you exit the sound, you shout, and then you hear your sound back maybe after 5 seconds. The 5 seconds will be the time that it took for you to be able to hear the sound back. That will be the time it took for the reflection of the sound. And when looking at the illustration that you're given, I said, and the question in the tutorial, to establish wave speed you have this formula: v is equals to distance divided by time, or wave speed is equals to change in displacement, which is similar to this d, divided by the change in time. So how do you go about with attempting this question? Looking at the data that you have wave speed, which is 340 meters in the second. You're looking for change in displacement. The time that you have, you're not going to substitute with the 4, because if you substitute with the 4, it's going to be an incorrect answer. Because the 4, it is the time it took for the reflection. The time it took for you to hear back the sound, not the time it took for the sound to move from the siren to the cliff. So, the t that you're given, which is 4 seconds, it is the time to the cliff and back to the siren, which is why it is a reflection. But when the time that you're concerned about, it is the time to the cliff alone, or the time from cliff to the siren. So it is the time for one way. It moved in one way, like in one way. Because if you look at this illustration, moving from the siren to the cliff, that is one way. But if you move from the cliff to the siren again, that is another way. Those are two ways. Those are two ways that this illustration is concerned about. It is to and from, to the cliff, from the cliff. But when that is not what you're concerned about. The time that you're concerned about, it is the time it took for the sound to move from you to the cliff alone. The time for one way, for one, how am I going to explain this? Yeah, for one way. Because from the siren to the cliff, that is one way. But from the cliff to the siren, that is also another way. Another time that it took for the sound to go back. From the siren to the cliff, it took a certain time. And also from the cliff to the siren, it also took a certain time. But when now what you're concerned about, it is the time it took for the sound to move from the siren to the cliff alone, or the time it took for the siren to move from the cliff to the person. One way. And in this instance, it took 4 seconds for the time for the sound to move from siren to the cliff and plus cliff to the siren. So it includes both to and from. But in instances where you're gonna calculate the distance from the ship to the cliff, you're gonna look, or you're concerned with the time it took for one way. So looking at this instance, it took 4 seconds for both ways, from the siren to the cliff and from the cliff to the siren. So how are you gonna go about calculating the time it took for one way? 4 seconds divided by 2. Why? Because we are concerned with 2 ways, and the time that we have here 4 seconds. So the change in time would be 4 seconds divided by 2. The 4, which is the total seconds back and forth, whereas the 2, it is the number of times that the sound is moving. It is moving from the cliff to the person, that is one way, and moving from the person to the cliff, that is also another way. That is why we have the 2. So you're gonna have 2 seconds. In instances where you're dealing with an echo, when you're given a time for reflection, you're always gonna divide it by 2. Always gonna divide it by 2 if you're given a reflection of a sound in terms of an echo, and the time that you're given is the time for the reflection and not the time for one instance. So you're going to say V is equals to change in displacement divided by change in time. The V, we have it, which is 340 divided by the change in displacement that we're looking for, divided by the time, which is 2 seconds. You're going to cross multiply by 2. So you're going to have a 340 you're going to have 340 multiplied by 2, and you're going to have 680, because if you multiply by 2 both sides, this 2 is going to cancel this 2, so you're going to have change in displacement as the subject of the formula. Therefore, the distance between the ship and the cliff is 680 meters. Keynote: when you are dealing with echoes and the time, in terms of time, echo is a reflection and reflection of sound. So if the statement say that it took 5 seconds for the person to hear back the sound or for the reflection of sound, just always know you divide that time by 2. The time, you're going to divide it by 2. Maybe the 5 divided by 2 for you to get the time it took for one way, because the distance from the ship to the cliff is a one-way distance. But if you go back from the cliff to the ship again, you're going to have to add that distance. So you're going to have 680 plus 2, and that would accommodate the 4 seconds time for the reflection of an echo. But if you're dealing with one aspect of distance, always divide the time by 2 in instances where you're dealing with reflections or echoes.